Hi, you guys. This is Mrs. McBride speaking. So, today I'm going to talk to you about matter. Some things that you probably already know about matter is that all objects are made up of matter. Matter has a mass and occupies volume. And you also know that matter can be acted upon by a force. You have someone, you push and pull on that person. Well, that person is a matter, and pushing and pulling is a force. You also know that the basic unit of matter, at least in chemistry, is the atom. You may also know this that the quantity of matter in an object is its mass. So the mass of an object is constant no matter where it is. That's because the amount of matter that it has is constant. So if you think about it for a second, your mass does not change whether you are on this planet or whether you are on the moon. The amount of stuff or matter that you have is the same within you, but it is your weight that changes from planet to the moon or anywhere else because now we've got gravity acting upon it. So there is a difference between both the word mass and weight. Mass only has to do with the amount of matter that is inside something. Okay, so those are some things you should know about matter. Today we are going to talk about the classification of matter, how to actually take different types of matter and classify it into different categories that help us understand it a little bit better and even know some of its properties and some of the changes that matter would go through. So you have this flow chart right in front of you. You need to learn this flow chart. This is an all year skill. It's everything in a nutshell that you really need to know about matter. So we've got matter here at the very top. And the question that we're asking is that can a particular matter be separated, physically separated? When I say physically, by physical means, I am saying, can this matter be sorted? Can you take a magnet maybe and start separating it? Can you filtrate it? Crystallization, can you crystallize something in there? Can you use density to maybe separate things? If your answer is no, I cannot take that matter and physically separate it, then we say that that matter is a pure substance. So can that pure substance now be broken down by ordinary chemical means? So by chemical means, I mean that does this pure substance become something else when you burn it, when it does rust, or when it combusts, which means to blow up? Does it, when it corrodes, when it rots, does this pure substance here become something else? If your answer to this question is that this pure substance cannot be broken down by chemical means, then we say that this substance is an element. Now, you've heard about elements. You probably have even heard about something called the periodic table. So the periodic table right here is the elements that cannot be broken down into by any chemical means. They are the simplest pure substance that is around. Examples of the elements would be silver, gold, carbon, hydrogen, oxygen, magnesium, iron, and even aluminum. So these are just a few examples of elements on the periodic table. Going back to pure substances, we can ask the same question, can this pure substance be broken down by ordinary chemical means? And if the answer is yes, the substance can be broken down, then we would call this substance a compound. A compound is made up of two or more different elements. So an example of compound would be glucose. Glucose is carbon, hydrogen, oxygen. Notice that carbon, hydrogen, oxygen are found on the periodic table. Then another example would be water, H2O. Both hydrogen and oxygen are found on the periodic table. And then you have carbon dioxide. You have carbon and oxygen that is also found on the periodic table, but because carbon and oxygen have decided to bond with each other, it is now considered a compound. So that's the difference between element and compound within the pure substance. Let's go back to this flow chart and relook at this where can this matter be separated by physical means? Remember, physical means to sort, use a magnet, but something that you can physically separate right then and there. If your answer is yes, it can be physically separated, then we say that this substance is a mixture. So what is a mixture? Well, a mixture is elements and or compounds that are physically mixed. So you have both elements and compounds that you physically mix together to make a mixture. Okay, so within a mixture, you have two different types. You have you need to look at how the composition of that particular mixture is. Is that mixture uniformly mixed or is it non-uniformly mixed? So if we say that the mixture is non-uniformly mixed, meaning it is a different composition, um, every single time, then we say that it is a heterogeneous mixture. The word hetero means different. So that should tell you that it is not mixed evenly or it's not mixed completely. So I'm going to write here, not mixed evenly. And that's a really big deal. So if it's not mixed evenly, we say it's a heterogeneous mixture. Example would be granite, pickle, relish, noodle soup. So if you have granite counters in your house, then looking at your granite counter, look at one section of the granite counter and compare that same pattern to another section. It is a little different. The speckles are different. You can even say that with the noodle soup. You can take a spoonful of noodle soup, one bite, and then have another bite of noodle soup and have a different composition of stuff that's mixed in your noodle soup. And then we have here for mixture, we have, is it uniformly mixed? If your answer is yes, it is uniformly mixed, that means that it is the same composition through and through. The word for that we use is called homogeneous mixture. Now, some people call it homogeneous mixture, and that's fine, but the word homo means the same. So it is the same composition throughout. Examples of a homogeneous mixture would be seawater, air, bronze, and brass. So if we were to take samples of seawater from different parts of the world and we were to analyze it, we should find the same amount of salt and water. Same with air. If we took samples of air from different parts of the world at even different elevations, we should, for the most part, find the same composition of oxygen, nitrogen, hydrogen, and other elements or even compounds. So this is just a brief overview of the classifications of matter that we have. If we go back, if we go on, and if we look at this picture right here that you have in your notes, now looking at this particular picture, you will be given pictograms and asked to analyze pictograms. Pictograms is a great way to understand what exactly is happening. The reason being is because from a pictogram, believe it or not, you can tell what kind of mixture it is. You can even tell if it is a element, mixture, or compound. So let's start off with the most basic pictogram right here. You have a pictogram right here. When you're looking at these pictograms, the two things that you need to focus on are size and color of these little atoms, sometimes even molecules that are present or compounds that are present. So let's look at this. Over here in the first pictogram, you have just one sphere. So this is actually representing a single atom. So because all of these atoms are the same color and they are the same size, that means that this is an element. Remember that an element, let's say if we have gold, then the element of gold, all of the atoms are exactly the same size. They are the same we they are the same size, they have the same characteristics, the same properties. So in this case, if we're talking about element, whatever element it is, we expect every single atom to be the exact same. Molecules, on the other hand, right here, this is also an example of an element. That is because if you're looking at this, they're the same color, which represents that they are made up of the exact same atoms. And then we also have the exact same size in all of these. So rather than this being the second pictogram being made up of atoms, this we call this pictogram made up of molecules. But this is molecule of elements, which is right here. Okay. So if we look at this next picture for mixtures, now notice that we have different color. And also, these atoms are different sizes. So clearly, this is not an element, but rather a mixture because it is made up of atoms that have different color. It's made up of different atoms. So the blue atom is very different from the orange atom. So we say it's a mixture. If you look at the second pictogram for mixtures, now you're looking at you have atoms right here, but then you've got here molecules of elements also. So this could be molecules of elements and then individual atoms also. This too is not, you have different colors and different size. So in this case, this particular pictogram is also made up of different elements. And so we would say that this is a mixture also. If you're looking at the third pictogram for mixtures, you can clearly tell in this case that you have molecules of the element, but they are a different color and they are a different size. So for this reason, we would say that this is a mixture also. And the last one you're looking at where this is molecules of a compound. Now this is a compound. Keep in mind that a compound is two or more different elements. So in this case, it's a compound and we've got one, two, three. So three different elements are making up this particular compound. So this mixture is not only made up of compounds, but then it's also made up of molecules of the element. So clearly this is a mixture. This is also a mixture. The last pictogram that we have is for compounds, and you can clearly tell that each one of these is a compound in here. So this is molecules of a compound. Okay, so moving on from there, if we talk about our last pictogram that we have here. So we've got a pictogram, two pictograms right here. Notice that one of them says homogeneous mixture, and then the other one says heterogeneous mixture. So if you look at the first pictogram where it says homogeneous, you know that the word homogeneous means same. Okay, so if you look at the substance, even though the molecules are further apart, they are evenly mixed. So all of the molecules are spaced apart, but they're evenly mixed. For that reason, we would say that it is a homogeneous mixture. If you want to go into more detail with this, realize that sodium is an element, chlorine is an element. Together, you've got a pictogram that's got the two elements in here. That would be sodium right here. And then you've got water, H2O. There are two hydrogens and one oxygen, a total of three elements, two different elements. So you would a total of three atoms. So you would have one, two, three right here. This would be your water molecule. So this is evenly mixed. But if you look at the second picture, heterogeneous mixture, hetero means different, And notice that there is a clump or a layer of molecules over here, but they're not really mixing with the molecules on top. So for this reason, we would say that this is a heterogeneous mixture because it's just not evenly mixing throughout the entire sample that we have here. So in this sample, the molecules are not evenly mixed. Of course, you have NaCl2 right here, 1, 2 atoms, H2O, which is a total of 3 atoms, 1, 2, 3 atoms right there. So, so if we go back to our original chart that we had here, classification of matter, um, one thing that I want you to understand is going back to mixtures, that mixtures do not have a definite formula. For example, compounds and elements have a definite formula, but mixtures do not have a definite formula. And elements and compounds, they both seem to have their own individual properties that are distinctive to the elements or to the compound that is present. But when you have a mixture, because it's a combination of several different things, its property is going to be a combination of whatever makes up that mixture. So I've got three examples over here if you're looking at this. And the question is which one is the mixture, which one's the compound, and which one's the element? So clearly, the first thing we should be asking, can we separate this through physical means? So of the three that we have, this is the one that we can actually sort through and separate everything through physical means. So this would be, in that case, since this can be separated, this would be our mixture that we have. So the next two substances that we have, we would say are the pure substance. But then the question comes down, can we break it down by chemical means? And for this, we would actually have to do some kind of an experiment or have to go through a chemical reaction to separate these two out and see whether which one's the element and which one's the compound. So if we were able to do a chemical experiment, then we could actually separate these two by chemical means. And you can see that this would be the element, this would be the element copper, and this would be the compound being water, H2O. So I really hope this helped you understand classification of matter and how to actually apply the concepts that we've learned to actual things that are around you in your daily lives. Thank you.